By early 2025, the AI conversation started to feel different. Not because of one big launch, not because of a single demo going viral, but because people working closest to the models were starting to pause and reflect. Instead of asking what's next, they were asking how far have we already come?
So if I'm being honest with myself, I think we're ahead of where I thought we could go. Starting work on LLMs in 2019 or 2020, it's kind of hard to believe the scale of everything we're doing, but also just what the models are capable of doing today.
That's a revealing thing for a researcher to say, because it suggests this wasn't just fast progress, it was progress that surprised even the people building it. At the end of the last section, Google's position in AI still looked uncertain. Google had invented the transformer, the core idea behind modern AI models, but OpenAI had moved faster in turning that research into products. ChatGPT became the default way people interacted with AI. Sora shaped expectations for AI video. Google's response was messy. Bard didn't land well. Early Gemini launches underperformed compared to competitor models from OpenAI and Anthropic. Image generation caused backlash and ethical debates due to biases. And the public takeaway was simple. Google was behind and looked lost in the AI race. But internally, the goal wasn't to rush out another demo. It was to rebuild the foundations. One of the biggest shifts in 2025 wasn't about a specific release. It was about how Google started talking about what it was building.
We're not really building a model anymore. I think we're really building a system at this point. People have sometimes this view that we're just training a neural network architecture and that's it. But it's really the entire system around the network as well that we're building.
That's an important distinction. A model is something you test. A system is something you run, maintain, scale, and improve continuously. And once you're building systems, progress looks different. It's slower to notice, but harder to stop. Gemini 3 didn't arrive with a dramatic moment. There wasn't a single feature that instantly changed public behavior. Instead, it showed up in lots of smaller ways. Better reasoning, more reliable outputs, stronger multimodal understanding, and importantly, an uptrend in users preferring outputs compared to competing models.
The amount of time people spend using the model to make themselves more productive internally is increasing over time. Every new generation of models is pretty clear the model can do new things and help us in our research and our day-to-day engineering work much more so than the previous generation of models. So that aspect should give us confidence as well that the models are becoming more capable and actually are doing very useful things as well.
That kind of feedback matters more than a leaderboard because it means the model isn't just impressive, it's useful and can provide real value. Over time, outside measurements started to reflect that internal confidence. On platforms like LM Arena, where models are compared blindly, Google's models began ranking at or near the top across multiple categories, such as text, image, video, and search. Not dominating everything, but rarely underperforming.
It's still remarkable how much progress we're able to achieve in this way, and it's not really slowing down. There's so many of these knobs and so many improvements that we find on a day-to-day basis. Yeah, almost on a day-to-day basis that make the model better.
That line matters, because by 2025, the question wasn't whether progress was possible, it was whether it would keep going. This is where Nano Banana fits into the story, not as the main event, but as a visible sign of the broader shift. After earlier image generation failures, Google rebuilt its image stack. The result was a model that did something previous systems struggled with. It kept people looking like themselves, faces stayed consistent, details didn't drift, and edits didn't fall apart. When Google submitted the model anonymously to LM Arena, it performed extremely well. Then it spread beyond technical circles, not because Google promoted it, but because people shared the results. For the first time, image models moved from look at this cool generation to how do we actually use this in our workflow. Teams started embedding the model into real design, e-commerce and marketing pipelines, including workflows inside tools like Shopify, Figma, Adobe Photoshop, and Canva. Nano Banana mattered less because it went viral, and more because it showed Google solving a hard, practical problem. That same approach shows up in video. With Veo 3 and 3.1, Google didn't focus on making the wildest clips. Instead, it focused on making video that holds together. Longer scenes, stable motion, embedded audio, and different types of cuts.
Hello, is anybody here?
Leading to usable outputs. For creators, the question wasn't, is this impressive? It was, how can I embed this into my workflow? Across text, images, and video, the strategy was consistent. Build tools people can rely on, then scale them. Google has been underestimated before, but 2025 felt different for a simple reason. The progress didn't depend on one product or one breakthrough. It came from lots of small improvements made by large teams, running on infrastructure built to support them.
There's a lot of small, medium-sized things that we can already see coming up, where I think we fix this issue, we fix this bug. This is an interesting research that shows promising things, and all of these things coupled, I think will drive a lot of the progress again.
That's how long-term advantages are built. So where does that leave us? OpenAI is still the most recognized name in consumer AI. ChatGPT still has the largest user base by a wide margin. And releases like Sora 2 and newer GPT-5 models show they're still moving fast. But for the first time, the gap is no longer widening. Independent data now shows Gemini steadily gaining ground.
ChatGPT visits grew 50% in 2025. They peaked in October, down 11% since then. Gemini usage, meanwhile, started its upward trend in November, right around the time Gemini 3 was released. In November and December, percentage gains for Gemini was nearly 30% versus OpenAI's traffic, which decreased about 6%.
That doesn't mean OpenAI is losing. It means something more subtle is happening.
The real signal in this chart is not that OpenAI is losing, but that Google may finally be converting distribution into usage.
And that distinction matters, because Google doesn't need people to switch platforms. It just needs AI to become normal inside the products billions of people already use. Docs, Gmail, Search, Android, Workspace, Maps, YouTube, and much more. If that trend holds, the next battle isn't awareness, it's retention. But there's a bigger question underneath all of this, one that has nothing to do with models, benchmarks, or user growth. Energy. Because as these systems scale, intelligence isn't the only thing they consume. They consume electricity at an unprecedented level.
Asking ChatGPT a question uses 30 times more power than a regular search query on Google.
And that's just inference. Training these models is even more energy intensive.
One study recently found that only AI uses could make up 0.5% of the entire worldwide electricity use. So this is an enormous amount of power.
That's roughly the same amount of power used by an entire country like Argentina, which is why the AI race is quietly becoming an energy race.
Google is the latest tech giant to press the nuclear button. It signed a deal to build 7 small nuclear reactors to power its AI data centers.
The first is expected this decade. The rest stretch out to 2035, which raises an uncomfortable question. If AI progress continues at its current pace, will energy become the real bottleneck? Google is betting that this isn't a 5-year problem, it's a 50-year one.
I don't think this is going to be an energy need for the next 5 years, but perhaps the next 50.
And that long view fits Google's strategy. Vertical integration, custom chips, purpose-built data centers, and now direct access to power. But it also reframes what winning the AI race actually means. It may not be about who ships the smartest model next year. It may be about who can afford to keep scaling at all. So as we head into 2026, the question isn't just who has the best AI, it's who can sustain it. Does Google's momentum continue, or does energy slow everyone down? Do nuclear-powered data centers become normal? Does AI efficiency improve fast enough to offset demand? Or does progress start to hit physical limits? Because if data was the fuel of the last decade, energy may decide the next one. And that could shape not just who leads AI in 2026, but how far this entire revolution can really go.